Dave, how's it going?
Oh, good. Thanks, Joe.
Yeah, cool. Good to have you on the show. I think there'll be a gamut of things we can talk about. I'm very curious about a couple of the books that I've read from yours. And I think last time we chatted, we talked about some interesting things you're doing with accounting, which doesn't seem like a very interesting topic in itself, but I'm sure we'll dive into why that's important.
All right.
Yeah, but for people who don't know who you are, do you want to give a quick intro?
Sure. I'm president of Semantic Arts, which is a boutique, I guess, consulting firm. There's about 30 of us who do nothing but help enterprises adopt knowledge graphs as their central data model. So it's kind of a journey of getting away from legacy systems to a future where data is born, integrated, and stays integrated.
Interesting. Walk me through that journey. How you realize the power of knowledge graphs.
Yeah, it's a journey because right now most large enterprises. In fact, this is an observation I made, and I'd love to hear somebody come up with a counterexample because I've seen this. We have a few clients that have 100,000 employees, and they have on the order of 10,000 applications, meaning 10,000 systems that are used by more than one person, supported by IT. And you come down to smaller, we have clients with 1,500 employees, and sure enough, they have 150 or 200 applications. Even somebody as tiny as us, you'd think 30 employees, we should have three systems, that we actually have closer to 20, which is very embarrassing, but we're working on that. But so the first observation is you probably have 10% as many applications as you have employees, and every single one of them has its own arbitrary data model and database behind it. And therefore, you've scattered all the enterprise information that you have into somewhere between 1,000 and 10,000 places. And when you want to understand what's going on with your patients or your customers or your vendors or this product or this incident or whatever, there's so many places you have to go look and so much expertise you have to go piece the thing together. I mean, people are just wasting all their time putting things back together that shouldn't have been taken apart in the first place. So our approach is to say, start with a model of what would it look like if it were all integrated. Start bringing data to that so it is integrated when you put it in that place. And then as you begin that journey, people, it takes a while, but they notice, like if you put all the employees and all, a bunch of things in the knowledge graph and people can see, well, it's all there. Maybe we add a few functions directly in the graph and start saying, that's one thing I don't have to do in the legacy system anymore. There's two things, and there's four, and there's 10. So instead of having these giant legacy modernization projects that never work, you just nibble away at it a little at a time, which is why it's more of a journey than a giant project.
That's interesting. Walk me through the topic of interoperability. Does that play any role either as a assistance or obstacle when you're trying to integrate the knowledge from all these different systems?
Um, yeah, I mean, we're more looking at what does interoperability look like at the data level.
Okay.
I think a lot of people, it's API or it's technology or it's protocol or something else, but secretly behind the scenes, almost all the data that an enterprise deals with is or should be connected to other things in the enterprise. You don't enterprises don't just randomly want to have a movie list or something that has not, unless they're in the movie business, in which case they want lots of movie lists. If they're making widgets, they want data about their suppliers and the materials and the machines and the equipment and all that stuff, and they want that integrated at the data level. If the data were integrated, they wouldn't worry about any other kind of interoperability.
Right. That's interesting. So Speaking of the books that you wrote, so the one that I've read two of them, Software Wasteland and the Data-Centric Revolution. So Software
Yep.
Wasteland, how would you describe it to the audience?
It's kind of trying to tell a boiling frog that they're boiling. It's really, that old parable of if you put, I don't know
Yeah,
if anybody's ever done this and harmed the frog, but they say if you put a frog in a warm pot of water and warm it up slowly enough, they won't notice. I don't know if that's true or not. It doesn't matter. But the enterprise equivalent is we've been adding applications to our enterprise infrastructure for decades now, and we've done it so gradually that nobody wakes up and goes, "Wait a minute, how come?" We had a client once who did some analysis and found that they had patient data in 3,000 tables in their various systems. Why does that not feel like you're boiling to death in a pan that's been slowly warmed up? If you have patient data in 3,000 tables, you have no idea what's going on with your patients.
right.
You'll never put that
That's
together.
crazy.
Yep. Yeah, it happens. We went into an insurance company while we were doing their enterprise model. In parallel, they did a data profiling project, and they discovered, well, before I tell you what they discovered, in the model we were building, there's exactly one place to put a social security number. It's attached to a person. There's a class called ID, and there's a subclass of it, IDs that are assigned by the Social Security Administration. There's only one place in the whole system you could possibly put a Social Security number. They found 8,300 places that they were storing Social Security numbers.
Wait, what?
8,300 places. This is a big
But there's
insurance
supposed to be
company.
one. There's supposed to
Yeah.
be one. You said. Okay.
Well, in their future, in a rationalized model, you'd have one.
Yeah.
In their
Yeah.
current architecture, application architecture infrastructure, they had 8,300 various places where
Whoa.
they found Social Security numbers. So what I
Wow.
said to them was, I said, that, and by the way, that's a PII problem. You've got all kinds of potential exposure. If somebody comes in, I said, it's like having 8,300 fingers to put in a dike. You've got 8,300 places this could leak. I said, I can't solve your problem. I can only make it 8,300 times simpler by having one place. Now, you can't go to what I just described overnight. That's why it's a journey. You just have to wake up one morning inside. I've been turning left into this quagmire, and it keeps getting worse. Maybe I'm going to turn the other way for a while. So anyhow, you were asking. My first book is trying to get people to be aware of just how bad it is. It's bad.
Mm-hmm.
It's, I talk about healthcare.gov, the $2 billion, the $100,000 system they paid $2 billion for. In fact, I even read, this is a great book, by the way, How Big Things Get Done. Anybody? Oh, I'm not on, I'm just audio. So
yeah, I'll make a note of it in the show notes, though.
It's a great book. This guy started his career looking at why mass transit projects always go massively over budget. And then he gradually branched into other things. Why do these always go massively over? And he finally gets to IT. Wow, why did that go massively over? Which they usually do. And he even mentioned healthcare.gov. But he seemed to think, just implied in the way he was writing this, that it was inherently a pretty big problem to start with, and it just got out of control. It is not inherently a pretty big problem. 6 guys in a garage did the equivalent, and it was better. And it's just the people that spend $2 billion on these kinds of things don't realize they spent $2 billion on a very simple system.
It was an interesting theme in Software Wasteland. The reason I mentioned this first is it sets the context. We could talk about the solution, right? But when I read that, I was just turning each page. I'm like, holy crap! There's a lot going on here. I mean, you cite many examples where the cost of implementation and services has in fact gone up over time, correspondingly, while you'd think they would go down. It's been nothing but going up, and it seems like there's every incentive in the world for the price to continue going up for a variety of reasons. And
part of it is perverse incentives. There's a lot of people in the the ecology that actually make money the more complex things get.
Yep. But you think this? I mean, so part of me, well, I think part of the zeitgeist is, I wouldn't say part of what I think, but part of what the zeitgeist would think, I suppose, is the cloud, for example. It's supposed to simplify everything and reduce costs,
Mm-hmm.
for example. But is
Mm-hmm.
this something that you've seen, or is it have you seen contrary to this?
It reduces a certain category of cost. The category of cost that it reduced was the administrative and operational cost of standing up a new instance. That for I don't know if you remember back in the early 90s, it would take several people to manage a server. By the mid 90s, one person could manage dozens of servers. That was their job. It was just getting a little more automated, a little bit better. Now, anybody with a credit card can spin up a server in minutes, So the administrative cost of a new compute unit has plummeted. That's brilliant. But for the most part, people haven't said, oh, while we're at it, why don't we rationalize our data footprint? And if anything, I would suggest that it's getting worse now because it's not just the cloud itself, but software as a service. If you decide to use a new service, you've put your data out in cloud number 22 or 17,000 or wherever it is in yet another data model, in another description of it. And yes, you can get the data out with an API, but now you've got your thousandth API with arbitrarily different fields, and somebody has to map them. And every time it's getting worse actually. So
That's interesting. When did it dawn on you that things were getting worse?
in the late 80s. So they've been
Okay, as
getting
far
worse
back as
for a
that.
while. Yeah.
That's a long time.
Yep. That was when it was when I built my second ERP system. So I think I'm one of the few people that I know of that's built two ERP systems from the ground up, custom built. And I was pretty proud of myself. But then I just started looking at this and started thinking about what's going on and why systems integration was becoming this big thing. And I realized it's because people want to solve point solutions with new applications. And there's plenty of people that are more than willing to say, yeah, I'll build that for you, or you can buy that from me or rent it
Right.
on the nowadays. And I think what's not happening is people are realizing I'm sub-optimizing. I'm optimizing this one little area and I can prove ROI, but at the same time, I've made the whole worse. I've just added,
Hmm.
I suppose in a way, it's like pollution. It actually benefits me to create pollution, but it makes the world worse.
That's a really good way of thinking about it.
Yeah, that just came up. I'll probably use that again.
You should.
Yeah.
You should. I'm going to steal on that one for a bit. It is interesting though, because I mean, so I mean, you're talking about a local optimization, and but
Mm-hmm.
globally it keeps getting worse. And we can talk about the impact of LLMs if you want. I'm curious. We can get back to the graphs as well, but it seems like if the data footprint is bad now, what was it? By some predictions, and these predictions are always hokey anyway, but take them from what you will. But
Mm-hmm.
it said by the year 2025, 95% of all the data online will be AI generated, or some number
Yeah.
like
Yeah.
that.
Yep.
So,
Yep. And we will,
but
I don't know. Yeah.
what do you do?
That's that's probably literally true. I mean, what's already true, we're generating data like we've never generated before. There's more data been generated in the last 3 years than the last 30,000 years or whatever. All those statistics are literally true, but what do they mean and what do they cause us to do? The
Mm,
first thing it means is that it's so overwhelming that we narrowly specialize. Data scientists will go grab 2 or 3 data sets and put them together and have some insight to where people have learned helplessness around trying to think of how all this stuff stitches together because it's too much. But yet you look at an enterprise, and even though they're dealing with vastly more data than they ever have before, I did a little graphic recently where I said, here's the top 25, I think it was, concepts from our enterprise ontologies that always show up every place we go. And there are no surprises. It's person, organization, buildings, equipment, events, transactions, blah, 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 all that, documents, stuff like that. And that almost everything in the enterprise is a specialization of those 25 things. And even as you go all the way down to the high volume, like Internet of Things, I've got 1,000 sensors out there in my factory, and each one of them is telling me exactly what the temperature is every second. That's a lot of data. And yet, if you look at the telescope from the other end, you'd say, oh, I see that I have a factory and it has equipment, and there I know where this sensor is. That's not high volume. You have 1,000 sensors. That by itself isn't high volume. You just want to connect to the sensor and say, okay, right now, what is the temperature? Or how would I get to what the temperature is last week when it went out of control? The whole, you should be able to understand the data, all that massive amount of data that you have through the lens of the small number of concepts you use to run your business. That's my thesis.
Well, it's an interesting one. So that leads us to the data-centric revolution, right? Which I think was your solution to the problem, right? And it talks about graphs, but it probably talks about a few other things too. And so, and I thought that was very captivating. So I have a lot of friends who are thoroughly involved in the knowledge graph space, and I am not, right? And I felt like it was a very interesting education. But how did you come across knowledge graphs as being a potential solution to the I guess how would you describe the sprawl that you're trying to manage? Was it data sprawl, or is it concept sprawl, or knowledge sprawl? What is it?
It's all of those. And you're right. Somebody asked me this question the other day, and I think there are two routes into graph. The route we took, and a lot of other people came in somewhere else, big data or something, but we came in through the semantic web route. Our first inkling was the reason that people arbitrarily make up different structures and names and level of abstractions to try and solve the same problem is because they just interview people and write down whatever they heard and draw boxes and arrows and crow's feet and build a system. And I said, well, what if there was a principled way of thinking that when you looked at the problem, you kind of rooted it in something in the real world. And so therefore, if two people looked at the same thing, they rooted it in the same real world concept. And that led to semantics. Or in the early 90s, there wasn't the semantic web. We were just studying semantics in general and kind of rolling our own. But then eventually by 2001, the semantic web was around, and we said, that's our route. We used that just to think deeply and design better models. And then as graph databases came along, we said, wow, that's the way to implement that. So that's how we came at it. But other people, I think, started with the data and big data and some of those problems and said, actually graph is a more flexible and powerful way to deal with that. So I think you can come to the same answer from different directions.
Mm-hmm. Yeah, because it seems like Google, they'd start out really algorithmically by using PageRank to make sense of it. A fun side note: my friend's dad came up with the paper that was the basis for PageRank, and it's fun to rank with that when I see him. Yeah, he's a math professor over here in Utah. But then what was it, around like the late 2000s or whatever? Google, started their whole knowledge graph project, and that really seemed to change a lot of things. It seemed like the
two fun facts. I would say that the two biggest acquisitions that Google made that changed their velocity, if you will. One was in the early 2000s. They acquired a company with the name of Applied Semantics. kind of an interest.
Mm.
And they're the ones that introduced AdWords and AdSense and all that kind of stuff. That's where they're first. And then, like you said, 10 years ago or so, they acquired MetaWeb and got Freebase, which was their RDF knowledge graph triple store thing. And it went quiet for a while, but then it reemerged. Google's knowledge graph, the reason that when you type something in now and you don't get a page, you type in UA 1813 and it doesn't take you to a page that talks about that. It tells you that flight is late now. It's because there's a graph and it knows what
Mm-hmm.
that means and what it's connected to. And yeah, that flight's late. You don't have to hustle.
Yeah. So what is it? What is the data-centric revolution?
It's first it's a recognition that by further splintering all your data, you're making things worse. So it's firstly that, and then the commitment to saying the way to make it better is to start with, and we say it's a single, simple, extensible model of your enterprise. And the single says there is a core somewhere. There's a few, and the simple part is there's a few hundred concepts that really stitch everything together. And the extensible says, yeah, in certain of your subdomains, you will want to elaborate on that and come up with more distinctions and make it, more fine. But the thing that holds it all together is the single, simple model at the core. So and then the part of the revolution and part of the journey is you begin by just copying data that you already have into this core knowledge graph, partly so everybody can understand it, because this stuff is so abstract, people don't get it until they see their very own data stitched together in ways they've never seen before.
Mm.
And then but at that point, it's just a smarter data warehouse in a way. I mean, it's better and it's more flexible and it's more connected and you can do certain kind of graph analytics. But then at some point you say, but you can also do ACID transactions right on the graph. You can build functional use cases and you can build them in a way that they're completely independent of each other because their integration's in the data, not in the system. And so you can start building use cases on the graph. And some of those, so the difference between this approach and a data warehouse or a data lake or anything like that, a data warehouse is always dependent on the legacy system as a feeder. That's where they get their feedstock. And if they were to ever go away, that there wouldn't be any warehouse. But the graph says, no, take a use case that you used to do in the legacy system and just start doing it. You've got all the data here anyway. Just do the use case directly in the graph. And then take another and another. And you just gradually, we call this legacy erosion. You just gradually start taking features away from the legacy system until you've nibbled it down to a size where you can finally say, I'm going to replace that. Right now, replacing a legacy system, legacy modernization, as they call it, is really a fraught operation. It's really hard to replace a legacy system now. Just because of what it's connected to and all that, ad hoc integration and stuff. It's hard to replace a legacy system.
Oh, if it ever happens. I mean, I was talking to somebody on a podcast today about how if you really wanted to make a lot of money, get into ERP maintenance and enhancements. You will never run out of work. These systems are gnarly.
Exactly.
Put it politely.
Yeah.
You've been around a lot, though. I mean, was it always the intention of these legacy systems to be so much of a guarded wall, I suppose, or
no? Actually, the original intention, SAP R2, which sort of was the first version, although there must have been an R1, but I don't think anybody ever saw it, was the idea was if you had a complete enough data model of your business and you could get everything in one app, you wouldn't have to do any integration at all. And that is literally true. It's true, but it's never happened. Nobody's ever gotten more than about 20 or 30% of their enterprise data in an ERP system. And now you still have to do integration, but you're integrating to probably the hardest possible thing you could ever integrate to. a system that has 90,000 tables is one that's almost impossible to understand. I met somebody once who claimed to be the worldwide expert in SAP product classification, because the SAP product classification model has something like 40 or 50 tables, and they're all joins, and you're just going, what? What? Are you kidding me? Anyway,
That's crazy. It's like the cab exam you have to take in London. So it's just
yeah,
you have to
exactly.
memorize every single nook and cranny of the city and hopefully know how to drive it. But that's insane. That's
Yeah,
insane. Somebody would spend that much time trying to understand that too. But I guess everyone's
yeah.
got a hobby,
Somebody
so
built it. So, once
that's
somebody
true.
built it,
Yeah.
then other people, and it's not like they have to understand it. They get to understand it, because once you're the world expert in SAP product classification and somebody wants to classify products, man, you got a gig.
Mm-hmm.
Just like your other guy was saying earlier today, go into ERP maintenance. There's a ton of money. Absolutely, I could make 5 times as much money as I'm making now, but my soul wouldn't let me. That would, I would just hate myself if I did that.
It seems like it'd be soul crushing work for sure.
It would.
Yeah.
Would.
So how do you take 90? Say, take an example. Is you mentioned a system with maybe 90,000 tables. How
Yep.
do you distill all that data down to something that will fit into a few hundred concepts in a knowledge graph?
Yeah. You would think that you'd need to do it bottom up, but it's incredibly hard to do it bottom up. You pretty much have to do it top down. You pretty much have to say, wow, what is it that well, by the way, it used to be SAP was almost entirely manufacturing. It was the follow on from MRP and MRP2 and all that. It was manufacturing resource planning, and then, or no, it was manufacturing requirement planning. Then it was manufacturing resource planning. Then it became enterprise resource planning. So they were just widening out the footprint around a manufacturing company. Now, if you put in a financial system, somebody says you just did an ERP project, and I always scratch my head and go, wait a minute, that's a general ed. Anyway. So how do you start? You start by saying, what is it these people do? They make something. And how do you make something? Well, you make something by having various manufacturing steps or recipe. If it's discrete manufacturing, you have these steps and additive and removative, processes. If it's, batch or continuous manufacturing, it's a different model. But, it's not that hard to conceive of the several hundred concepts you need to understand what the business actually does. And once you're armed with that, then you go look in these systems and say, well, where are the vendors? Where's the supplier? Where are the products? Where's the specifications? Where's this? Where's that? Okay. Now I got it all. And when you do that, you then say, okay, what else don't I have? And it's surprising. People go, well, I guess that's about it. I mean, we did this project for Schneider Electric many years ago where we took their product catalog, which is very complex. They have 1 million products because they're huge and they big industrial stuff. And they had a catalog with 700 tables and 7,000 attributes, I think. And we did this modeling process. We got all the data about everything about their products, specifications, also the prices, which markets they were being sold in, all that kind of stuff. Put in the knowledge graph, and the knowledge graph, the enterprise model had 300 or 400 concepts. But when we looked, after we loaded it, we'd only populated 46 tables and 36 properties. We went, wow, that's kind of amazing, because it was obvious that everything was there because we were doing these user front ends and surfacing up all the specifications and doing product compatibility, all that kind of stuff. But what was interesting, what made me think of it, they then said, oh, we acquired this other company that also has a product catalog and it's arbitrary and different. Well, once you know I'm only looking for these 46 concepts and 36 properties, you go over to the other system and say, where are those? Somebody knows. Where do you have the product specifications? Where do you have the market prices? Where do you have the availability, blah, blah, it's here, it's here, it's here. Okay. You suck all that out and you suck it all out and you say, is there anything else that was in that catalog that we needed to surface? And in this case, interestingly, they said, yeah, we have this thing called aesthetic groups because Schneider, which does industrial products, they don't care much about the aesthetics. But this other company had residential products where you have light switches and plugs and stuff, and they care a lot about whether slate gray will match with charcoal gray or whether bone matches with ivory, and stuff that an industrial person, no, that's white and black. Okay, so we had to extend the model by 2%, add that. That's it. I think that's the idea, is that you have to start understanding the whole, and then the pieces make sense. If you start with the pieces, I don't think you'll ever get there.
Reminds me of a conversation I was having with John Giles.
Name sounds familiar.
He wrote a few books on data modeling. He I think shares your same publisher techniques, but he was advocating from a data modeling perspective, right? I mean, I think in much the same way, it's his rallying cry was that we were too fixated on, kind of the nitty gritty, right? I think to your point, the bottoms up approach, and he was really a fan of these particularly these books by Lev Silverstein, I believe, about data modeling patterns, right? There were 3 of them, and those were things that he had been advocating, is that revisit the ideas of using patterns to really understand at a conceptual level. How should you think about your business? It seems like what you're describing is somewhat related to this, where you're starting with a top down, really macro perspective, and then working down.
Yeah,
that's really interesting.
And you have to ground yourself in reality. You don't want to build these beautiful models in the sky and never tether them. Right. Then you go down and say, okay, give me the real data. There's a lot of work there. How does it actually map? What did I miss? What is this extra concept you have here that doesn't make any sense? So you do get down. You have to get down to that level of detail, or it's not real.
Right. So, I mean, how did you discover then a lot of the ways of seeing a business? Because I can't imagine this is something that you just jumped into this overnight and said, I understand how an electric company works. Obviously, it's Schneider Electric. This is a piece of cake. Let's do this. I mean, how do you develop that ability to look at a scenario like that and really understand what's going on?
I mean, it is patterns. That's and if you do enough projects in enough different industries, and especially if you're focused on the semantics of the data, after a while you just see they just show up. It's like what was that, Sherlock, or one of those movies where the guy would just see things in the air, and it is like that. It's weird. You can learn it, but I think it takes a while.
Mm-hmm. Yeah, I mean, you've been in the game long enough. I would think you probably are one of those people who can sort of, I think, as they say, see behind walls. Like, you just know what's ahead, right? And that's it's just sort of a Jedi trick that you develop over time. But like you mentioned, the semantics of the data. Like, walk me through that. How, if somebody was trying to understand or learn about how to see the semantics of the data, what would you recommend?
Yeah, that's a good one. There's 2 ways to come at a problem. One is a semantic ways of coming at a problem. One is you look at a bunch of terms and say, what do these terms mean? And people do that a lot, vocabulary projects and taxonomy projects, all those projects. But inevitably, there's huge numbers of terms, and people get kind of lazy and they just say order date. That's the date of the order, and all those just trivial transpositions of a label. What ends up being interesting is if you stare at it and try and map it to the real world and say, what are actual instances of that concept that the light will go on, and every place we've ever been, whatever the most common terms are the ones that people are secretly in disagreement about. So, for instance, if you go into a manufacturing company, you talk about products, I can guarantee you there's one of 3 things you're talking about, and people just talk past each other and have no idea that they're even talking past each other. One thing is a physical thing that has been made that you could drop on your toe and hurt yourself, and you would if it was valuable enough, you'd put a serial number on it or a RFID tag or something like that. It is a specific thing that weighs something. But when somebody has an inventory system, they think that the inventory system is describing products. And only if it's actually at the serialized part number are they. They have a specification for what determines this is a widget and this is a gadget, because widgets have, 300 pipe lengths per inch or whatever, threads per inch. But, there is some difference between two reasonably similar products. And when you say product at that level, when you're talking about a SKU, you're really talking about a specification. And you can put 100 of them in the bin and nobody cares which one they take out. And then the third time when somebody says the word product, they mean things that we've learned in general about these kinds of products. That's almost a knowledge level. So you got, and if you just use the word product for all three, which people do all the time, you will always be confused. And so you just have to, you have to start from what's real. There is something real in the real world, and it sometimes it takes a little to tease it apart.
Yeah, for sure. I mean, yeah, objectively there has to be. I mean, people are selling something and making money off it. It's not like they're selling nothing, hopefully. So.
Unless you're selling NFTs, for instance, where you really are selling nothing, but it caught up to them, and now they're now NFTs are worth less than Beanie Babies. Can you believe that?
Yeah, which is crazy. I keep thinking about that person that spent $69 million on a NFT. Which is, that's insane. Well, the money went somewhere.
Yep.
Last time we spoke, we were talking about some of your thoughts about accounting,
right?
And knowledge graphs.
We stumbled into that one accidentally. Back in my early days when I built these ERP systems, I worked for Arthur Andersen, the accounting firm, but the consulting division, which eventually became Accenture. And back then, I really knew accounting systems. I built a bunch of them. I knew exactly how they worked. But I just noted, two things happened more recently. One, we decided, we have a practice. We help people adopt knowledge graphs, all that kind of stuff, mostly large-ish, medium to large companies. And when I said it was a journey, it's kind of gradual. It takes a large company a while to even get a moderate footprint of this stuff. And I was thinking, man, I'd really like to get a medium-sized company, completely data-centric, so we could point at it and say that, that's what we're talking about. And then we said, well, in order to do that, I think you'd have to have a starter set. You'd have to already have the ontology pretty well built out and most of the use cases built out with model-driven development so you could change them as you need to. And then it's mostly just a conversion project, and you could probably do that in a year or two or so. It's at least doable. But then when we sat, and then the second conclusion to that is, but in order to have a model and the use cases, you pretty much have to pick a vertical industry. So you pick something. And we said, well, let's pick something we know, professional services, because it looks like there's a market for architects and engineers, and maybe even lawyers and accountants, who knows. And as we started diving into that, we went, wait a minute. There's accounting in these. In fact, it's a big part of a professional services firm is time control and invoicing and all that stuff. And I said, wow, we've been doing this semantic stuff for 23 years now, and we haven't touched accounting. And my first thing was, why haven't we touched accounting? I think most of our clients wouldn't let a small company like us touch their accounting systems, or they think it's a solved problem and they've spent hundreds of millions of dollars. Of course it works. But when we got into this and really started thinking deeply with the semantic lenses on, it was like, whoa, the future of accounting doesn't look anything like it currently does. It's going to be, there's, spoiler alert, no debits and credits and no account numbers. Other than that, it's going to be GAAP compliant. There's, everything that we love about accounting and not all the crap we hate about it. when you look at it semantically, um, accounting is the recognition that a business event occurred, and almost all, 95% of all business events occur outside the accounting department. Something happens, and it eventually makes its way to the books and records of the firm and gets monetized and categorized and classified and all that temporalized. And that journey is largely systems integration. It started in a procurement system and it went over here to an inventory system, and somebody issued something, and then we got a issued ticket and FIFO, LIFO, here's the cost, and we have to book it to revenue recognition or not revenue recognition, all that stuff until ta-da, here's your financial statement. 15 days after the end of the month, by the way. You will know what happened, 45 days after it happened. But if you really stare at it, you go, wait a minute, business event, convert to triples. You can, now it turns out, I thought this was going to be way harder than I originally thought, because and I used to read these giant FASB things about revenue recognition, all that kind of stuff. Turns out for any given company, you can condense that down to a model of really a few hundred triples. It says when this kind of event occurs, here's the policy and the rules, here's how to cost that, and here's where it goes in the financial statement, and it will be there in a few seconds. Now, I think there's some people that would find that incredible. There's some people that would find that about as scary as anything could possibly be. I mean, this is going to be very polarizing.
Interesting. That's really interesting. Are you planning to, I guess, publicize any of this at some point, or?
Yep. We're writing a book. We had it mostly written, but in the middle part of the book was a worked example, and I just worked it in Excel and a bunch of arm waving, and I thought it was going to work. And I thought, I have to actually sit down and program this and make sure it really is going to work. Well, it turns out my first couple of ideas were a little off base and not quite. So I'm just about got it now. In fact, I think this weekend I can finally get the last few touches on this.
It's cool.
To prove that it works in a prototype, then we're going to do it in our own company. But once that's ready, we're going to finish the book, publish. I have a accounting professor, Cheryl Dunn, is working with me on it. We have a publisher. Yeah, we're going to have a book that describes how this works.
Oh, that's really cool. I'll have to get you back on one of my other shows. We can show it off. Yeah. That sounds really cool and really captivating. I definitely see what you mean, where it could definitely be polarizing too, because there's definitely people who my wife's her training is in accounting, for example, and accounting to her is very much like, this is how it is. But other people though, I mean, because I would always use accounting data for stuff I was doing, with analytics or data science, whatever. And I always wish there was more flexibility. I definitely wish it was more timely than whenever the hell it was updated. The closing the books ritual is an interesting thing, or it feels like we do it because we've done it that way.
Mm-hmm.
Right.
Absolutely.
Because that's it's not like the good Lord mandated that you had to close your books on these certain days the way we do. It was just that's habit, and that's how it works. So it's there's banking hours and there's accounting department hours, and so these are it's very set in stone. I guess it's kind of closing out a bit. You've written how many books have you written?
Just the 3. The one you haven't read was much earlier. It was called Savvy Guide to Business. What was it called? I forgot. Semantics and Business Systems. That's what it was. And it just made the case for why you should think semantically about your business system. I mean, I think it was correct and everything, but it didn't really catch on or catch. It may have been too early, and it wasn't specific enough, I think.
Interesting. Why do you like to write?
It helps me think, not just books, but, articles and things like that. There's something about the writing process and the presentation process that forces you to articulate ideas that may be a bit fuzzy in your head and make them more clear. And once they're more clear to others, they're also more clear to yourself.
Makes sense. Yeah, I'm always curious if people go through um, the joy and the punishment of writing a book. It's
Yeah,
it's a lot of
it's a
work,
slog.
as you know, and
Yeah,
it is, but it's a it's a labor of love, as the old cliche goes too. I don't think I'll stop. I don't think you don't seem like the kind of guy who's going to stop either. It's number 4 for you, so it's pretty awesome. When do you think
yeah.
this book will be out?
Probably in the spring.
Spring? Okay, cool.
Yep.
The schedule for something for there. Well, awesome. I know you're a busy guy, and we're about at time, but yeah, thanks for the fun chat. I definitely learned a lot,
Oh yeah.
and thanks for writing
Thank
the
you.
2 books as well.
Yep.
So yeah, the
Yeah.
like I said, Software Wasteland really changed my viewpoint on the way we do applications, and it's not easy for me to get swayed by a book that often. I read a ton of books, and
Oh, good.
yours was definitely. I don't know what it was about it. It was just I think the tone that you took, and I think you're very straightforward when you write, which makes you a lot more credible. Some people are very hand wavy and I think beat around the bush, but you're kind of no BS when you write, and I think that's conveyed it really well. So
Oh, thank you. Appreciate that.
yeah, of course,
That's,
awesome. What's that? Sorry. Cool. Well, for people who want to learn more about you, how can they find you?
I think the website's the best, semanticarts.com. And take it from there. I'm happy to take an email, McComb at semanticarts.com. It's pretty easy.
Good. All right, Dave. Well, thank you for your time. Talk to you
Yeah,
soon.
you bet. Thanks, Joe.
Yeah, good luck on the book. All right, take care. Bye.
Thanks. Bye.